Good morning. Welcome to another week of online learning. We are going to continue on with our conic section chapter. Last week we talked about parabolas. The week before that we talked about circles. This week we are going to talk about something very similar to a circle, something called an ellipse. So let me go ahead and share my screen here. I hope all of you are having a fantastic start to your week. Okay, so here I have a graphic about our conic sections. So the very first one we have here is a parabola. That's what we talked about last week. The second one here is a circle. If we take that double napped cone and we take our plane and slice it through at a diagonal that doesn't go through a base, you can see that we have what looks to us like an oval. Okay, this is what we call an ellipse. It's basically a squished circle. Okay. So an ellipse is defined to be the set of all points in an XY plane, in a plane, whose sum, the sum of the distances from two distinct points is constant. Okay, now I know you're going to write that down. Okay, in a parabola, we have what's called a focus. In an ellipse, we actually have two of them. Okay, so the plural is what we call foci. One focus, two foci. So inside of our ellipse, we have these two special points, the foci, where when we take the distance from focus to point and focus to point, when we add them up, it will always be the same. Mrs. Homan, what does that mean? Okay, well, if we go here to this ellipse, okay, I want you to notice that right in the middle, there is an addition problem, okay? And right now it's equaling 10.57. That addition problem is taking the red dotted line and the blue dotted line and adding them together. That red dotted line is going from the focus to the point, and the blue dotted line is going from the focus to the point. Okay, and as I rotate this around, notice how that sum is always the 10.57. The 10.757, excuse me, that number is not what's important. It's that it's staying the same. Okay, I can take my ellipse and make it a little bit more squished. Notice how that sum is a different number because we have a different ellipse. But as I take the point and I rotate around the points of my ellipse, that distance is the sum of those two distances is going to add up to be the same thing all the way around. Okay. Okay. Now, there's a lot that goes into an ellipse and there's a lot of symmetry that happens. Okay. We have a center, okay, much like we do in a circle, we have a center, and there's both vertical and horizontal symmetry, okay? Now, depending on how our ellipse is situated will depend on which one is major and which one is minor. So we have what's called a major axis that is going to go through the center, but also the endpoints are going to be what we call our vertices. Okay, one vertex, two vertices. And then our minor axis is going to be perpendicular. It's going to be the shorter of the two. So our major axis is always going to be the longest, and our minor axis is always going to be the shortest. Okay. So what we are going to focus on to make these shapes for our ellipse, we are going to focus on the center. We are going to focus on our two vertices that lie on our major axis. And then we're also going to focus on these points at the end of our minor axis so that we can get the shape of our ellipse. Okay. Okay. So just like we had for our parabola, we have the standard form for an ellipse. Okay. Now today in this lesson, I'm only going to focus on the horizontal ellipse. Our vertical ellipse will be in Ms. Cronke's video, which you'll watch next. Okay. So here is the standard form for a horizontal ellipse, which means, like in the picture below, the major axis is going to be horizontal. So the longer part of our ellipse is going to be horizontal. Okay, so go ahead and write that down. Our center is still going to be at HK, just like it was with our circle. Okay. Okay. Notice how A is larger than B. Okay, this will become more important in the next lesson when you know the difference between horizontal and vertical. But A is the bigger number. And since A is the bigger number, and in this case, it's underneath the x minus h squared, that is what's telling us that this is a horizontal ellipse. When the x squared has the bigger denominator, we are a horizontal ellipse. Okay. Now, what do these A and B numbers have to do with anything? Okay. A is going to give you the distance from center to vertex. Okay. So once you have your center figured out, we can go horizontally out that distance A to the right and to the left in order to get our two vertices. Then B is going to give us the distance from center to minor axis endpoint. Okay, so once we have the center and we know that it is a horizontal ellipse, we can plot our two vertices, but then we can use B to go vertically up and down from our center to get those coordinates. Okay, finally, the foci are the most important part of these ellipses. Okay, because of the property that we talked about in its definition. The foci are going to be C away. I know I haven't told you how to find C quite yet. Just hold on. But what's going to happen is we're going to, from our center, since this is a horizontal ellipse, we're going to go horizontally to the right and to the left, C units from the center, in order to plot our two foci. Okay, Mrs. Holman, how do we calculate C? C can be found by taking C squared equals A squared minus B squared. Please make sure you write that down correctly. C squared equals A squared minus B squared. Okay. Now, one last thing I'm going to talk about before we get to an example is something called eccentricity. This is something that measures how oval or how squished our ellipse is. Okay, so if we take C divided by A, that's going to equal E, our eccentricity. And that tells us, well, it's a number between 0 and 1, and it tells us how close it is to being a circle versus how squished it is. Okay. Okay, so here's our first example. X squared over 9 plus y squared over 5 equals 1. Notice how this is in standard form. We have the x squared over a number plus our y squared over a number equals 1. And that's really important that it equals 1. Okay. So let's talk about how we know it's horizontal. We know it's horizontal because of the two denominators, the one under x squared is bigger. So we know that it is a horizontal ellipse. Okay? So it's a horizontal ellipse whose center is at HK. Now, since x squared and y squared, there's nothing like in parentheses subtracting them, or subtracting inside parentheses, we are going to say that our center is at 0, 0. Okay, I wanted to keep it simple here for our first example. Okay, now, since 9 is the larger of the two denominators, 9 is what we would consider to be a squared, which means a is 3. Okay. So since this is a horizontal ellipse, we are going to go 3 to the right and 3 to the left for our vertices. So I just plotted my vertices at 3, 0 and negative 3, 0. Okay. Now, this means that 5 is b squared, which means b is radical 5. Okay. So when we plot the endpoints of our minor axis, we are going to go up radical 5. It's just going to be a little bit bigger than 2. And down radical 5 for our two minor endpoints. So I'm going to go ahead and have you label these minor endpoints. Okay, so 0 radical 5 and 0 negative radical 5. Okay. So here is our ellipse. Okay. The last thing that I'm worried about are the foci. Okay. So if you recall, we calculate C by taking C squared equals A squared minus B squared. Well, we know that A squared is 9 and B squared is 5, which makes C squared 4. All right, so we know that C is 2. Since this is a horizontal ellipse, we are going to go horizontally 2 from the center to plot those foci. So our foci are going to be at 2, 0 and negative 2, 0. Okay. Something that I should mention, up here, like for B, since we had an irrational number, please leave it as an irrational number. I do not want decimal approximations. I know we had to think about radical 5 as 2 point something in order to plot it, but I really need you to leave it as a reduced radical. Okay. Okay. When you graph an ellipse, we need to identify the center. Then you can plot your vertices. Then you can plot your minor endpoints. Then you can plot your foci. I need all of those things in order to know that you understand what's going on with your ellipse. Okay, last example. Okay. Notice how this is not in standard form, which means we're going to have to get it there. Okay, we need that x minus h squared and the y minus k squared. And since we don't have it, yes, you've guessed it, we're going to have to complete the square 2 times. Okay, so the first thing that I am going to do is I am going to rearrange this so that my x is with my x squared and my y is with my y squared. Okay, and I'm going to take a little break and I'm going to talk about how I know that this is an ellipse. So first of all, there are 2 squared variables, so I know it can't be a parabola. Okay, well, how do you know the difference between an ellipse and a circle? Okay, if this were a circle, then both the x squared and the y squared coefficients would be the same. But since it's an ellipse, the x squared and the y squared coefficients are different, but they're both of the same, they're both positive. They could be both negative, but we don't see that very often. But they're both positive, but they have different coefficients, so we know it is going to be an ellipse, okay? Now we're gonna have to complete the square with both the x's and the y's. So I'm gonna go ahead and get ready for that. Oh, let me change my color here. So we have x squared plus 6x plus a mystery number. That y squared needs to have a coefficient of 1. So I'm going to factor out a 4 from y squared and negative 8y. But I'm going to leave 9 alone. And then we will have to balance out our equation with our 2 mystery numbers. And my 0 I can't fit. Just know that there's an equal 0 right there, okay? Everyone write it with me. Equals 0. Mine's just off of the page, okay? So then let's talk about completing the square. We know that b over 2 squared here for 6x would be 9. And we know that b over 2 squared here for negative 2y would be 1. But remember, this 1 is attached to the 4. So I wrote 1, but we really added in 1 times 4. Okay, so what we have is x plus 3, the quantity squared, plus 4 times y minus 1, the quantity squared, minus 4 equals 0. The 9 minus 9 went away, so we just had the minus 4. Okay, we are closer, but we still are not in standard form. Okay, this minus 4, I think, shouldn't be on that side. So I'm going to go ahead and that whatever constant you have once you have completed the square needs to be moved over to the other side. Okay, but then remember, we need that to be equal to 1. So since this is not 1, we have to make it 1, which means we need to divide both sides but by whatever that number was. So we have x plus 3, the quantity squared over 4, plus y minus 1, the quantity squared over 1, because we have that 4 over 4 right there, equals 1. And here, ladies and gentlemen, is the standard form for our ellipse. Okay. All right, we know that this is an ellipse, and we know that it's horizontal because the bigger denominator is associated with that x squared. Okay, so let's identify everything that we need to. Our center is going to be at HK, negative 3, 1. Okay, then we need our vertices. So remember, this is a squared, which means a is 2. So I'm going to move horizontally 2 from both sides of our center. Okay. So our vertices, I'm going to plot them, then I'm going to write them. Our vertices ended up at negative 1, 1 and negative 5, 1. Okay. We know that this is b squared here, so we know that b is 1. So our minor endpoints are going to be up 1 and down 1 from our center. So these are at -3, 0 and -3, 2. Okay. All right, let's see if I can draw this. Ooh, that actually wasn't so bad. So there's our ellipse. Okay. And then the last thing we're going to talk about are the foci. Okay. So remember, c squared is a squared minus b squared. A squared was 4, b squared was 1. So c equals radical 3. We know that radical 3 is a little less than 2. So we are going to plot our foci a little bit less than 2 away horizontally from our center. This is a horizontal ellipse, so our foci need to be horizontal. Okay. Now, you may be wondering, oh, Mrs. Homan, how are we going to write those foci? Okay. From our center, we went to the right radical 3. And from our center, we went to the left radical 3. So from my center, I added radical 3 to the x-coordinate since we went to the right. And from my center, I subtracted radical 3 from the x-coordinate since we went to the left. Okay. And then the last thing that we can talk about here is our eccentricity. Our eccentricity is c over a. So radical 3 over 2 would be our eccentricity. Okay, so you have an assignment that has both horizontal and vertical ellipses. After watching this video, you are ready to try the ones that are horizontal ellipses. Okay, hope to see you soon.